Hey guys, it's Miss Johnson and I'm here to bring you our Unit 3 Notes 5 lesson video. Today we're talking about negative exponents. So our learning target is I can simplify expressions with negative exponents. So we've talked about multiplying exponents, we've talked about dividing exponents, we've talked about adding and subtracting exponents. Now we're going to think about what do we do when we have negative exponents. So here's our rule. When you have a negative exponent, you're going to want to invert the location of the term with the negative exponent and make the exponent positive. Okay, invert the location of the term of the negative exponent, and I'll talk about what that means because that's probably kind of some tricky wording. And then we make the exponent positive. So a very, very brief example. Let's say I have the term x to the negative second power. Okay, we cannot leave negative exponents in our answers. We always have to flip them and make them positive. So right now, if I think of this as a fraction, this is like x to the negative second over 1. I'm going to invert that term. I'm going to take that term and I'm going to move it down to the bottom, and I'm going to make the exponent positive. When you flip it across the fraction bar, the exponent changes signs. So if I flipped it back up, it would go back to being negative. When you invert it or flip the location, it changes signs. So since I want my negative to turn positive, I'm going to move it down. Now, there was nothing else up top here with the x squared. There was just a 1 in front, so it's just a 1 on top of that fraction. And that is what my new fraction looks like. So when you flip negative exponents, one thing we need to be careful of is to only flip the variable with the negative power. We only flip the part that has the negative power. We don't flip the whole thing. We only flip the part that has the negative power. So that's something to take note of. So let's take a look at some examples. In number 1, we have 4 times a to the negative second power. So the piece that has the negative power that I can't leave is that right there. So I'm going to take that a to the negative second and I'm going to move it down. My 4 stays on top. So I have 4 over a to the positive second power. There's nothing else to simplify, so I leave it like that. In number 2, I have 1 over 3 times x to the negative 1 power. This x to the negative 1 can't stay that way. Now the 3 is not being raised to the negative first power, only the x's. If this were in parentheses, that would be a different story, but it's not. So only the x needs to get raised to moved up to that other location. So I move it up to the top. That means I have 1 times x to the first over positive 3. The 3 stays on the bottom. Now, when you look at 1x to the first, we don't actually need to write a coefficient of 1, and we don't need to write a power of 1. So this is really just x over 3. In number 3, 6a over b to the negative second. So I need to take that b to the negative second, and I need to move it up. So I end up with 6a times b to the second over 1, because there was nothing else left in front except the 1, and we all know that writing a denominator of 1 doesn't make a difference, so I just need 6ab to the second. In number 4, I have that b to the negative third, that needs to go down, and I have a to the negative second that needs to go up. So I'm flipping 2 things here, but notice the 4 just stays on the top. 4 is not going to change. So I have 4 a to the second over b to the third. So my a moved up and became a positive power, my b moved down and became a positive power. There's nothing else to reduce, so that's what those negative powers look like. Now let's just revisit those properties of simplified monomials. We've seen these before, but now we have a new one to add. So 1, each base appears exactly once. We don't want to see a variable more than 1 time. So we only want to see 1x, we only want to see 1y, we only want to see 1b, and so on and so forth. We also need to not have any power of powers, meaning we need to get rid of all parentheses. Anytime you see a set of parentheses, that means there's something we got to do to fix it. Whether it's distributing a power on the outside or putting like terms together, we have to fix it, okay? So no power of powers where you have, some number out here. We also need to reduce all of our fractions. For example, if I had 4/6, I need to reduce that to 2/3. So reduce all of our fractions. whenever we see them. And now the new one is no negative exponents. We are not allowed to have negative exponents in our answer. Okay, so we need to make sure that none of these things are in our answer. All right, so let's flip over and do a bunch of questions on the back. In number 5, I have the two terms that are being multiplied together. And one of them has a negative power. I'm going to start by making this one term. I'm going to take these two things and put my like parts together and then see what I'm left with. So that means I need to take 2 times 7, which gives me 14. And I need to take x to the third times x to the negative 1. That means I'm adding 3 plus negative 1, which is 2. So that's just x squared. Now at this point I would check all of those things. Do I have a fraction reduced? Do I have a negative exponent to take care of? All of that. And in this case, I don't have anything. So that's my answer. In number 6, I have negative 5 out front that gets multiplied by 12. Negative 5 times 12 is negative 60. So negative 60. And then I need to put my a terms together. So a to the fourth times a to the first, add those up. 4 plus 1 is 5, so that's a to the fifth. And then b to the negative sixth and b to the second, negative 6 plus 2 is equal to negative 4. So technically I have b to the negative fourth. So that's what happened when I took these two terms and multiplied them together to make one. I now need to fix things. I now have things that I have to take care of. So the negative 60 is fine, it's not a fraction. A to the fifth is fine, it's positive. But b to the negative fourth is negative. That needs to move down. So my negative 60 and my a to the fifth is going to stay on the top. And on the bottom, I'm going to have b to the positive fourth. That is my final answer. Let's take a look at number 7. In number 7, we have b to the negative third, c squared, over d to the negative fifth. So negative powers need to move down. This moves down. This moves up. C squared stays because it's not negative, it's already positive. So I have c squared on the top. Now I also have d to the positive fifth on the top. And I have b to the positive third on the bottom. Each variable's there only once. Everything's simplified. Fraction, there's nothing to reduce. I'm good. How about number 8? So look for your negative parts. Now, again, we're only looking for negative exponents. This negative 3 is a coefficient out front being multiplied, so I don't need to worry about that. But I am going to take care of this negative exponent. So a to the negative fourth, that needs to move down. C to the negative fifth, that needs to move up. And then let's see what we have. So I have negative 3, the b to the seventh, didn't move. C to the positive fifth, because I moved it up. In the bottom, I have 21. I have an a squared that was already there. I have a b to the seventh that was already there. And then I have another a to the positive fourth that I need to move down. Okay, so now let's take a look at the parts that need to be simplified. So 1, I know that I can reduce this. Negative 3 over 21, take out a 3, that's equal to negative 1 over 7. So that's going to change my fraction. This will be a negative 1, that'll be a 7. I also need to fix some variables. So on the bottom, my two a terms can go together. 2 plus 4 gives me 6, so I have a to the 6th power. And then my b terms, I have b to the 7th over b to the 7th. That's a subtraction question. That's subtracting the powers because one's on top, one's on bottom. And 7 minus 7 is 0. So really, your b's are going to cancel out. So now let's take a look at what I have left. I have a negative 1 on top. C to the 5th I didn't touch. On the bottom, I have a 7, and then I have a to the 6th. Now I will tell you, this is a perfectly fine answer. I would accept that and not take any credit off on a quiz, but on a multiple choice test, this negative 1 you would not see. You would just see a negative c to the 5th, fifth, over 7a to the 6th. Or you might even see that negative out front of the fraction as well. but that one coefficient you probably would not see. Okay, let's take a look at number 9. In number 9, I have negative 3, q to the negative second, r, s to the fourth on the top, holy buckets, and a whole bunch of stuff on the bottom. Let's find the negative parts that need to flip. So this needs to move down. This needs to move up, and this needs to move up. So let's rewrite that. Negative 3 I didn't touch. R I didn't touch. S to the fourth I didn't touch. I moved that R up. R to the third. I moved that S up. S to the fifth. Bottom. Negative 12 I didn't do anything. Q I didn't do anything. Q to the negative second I moved down. So that's really times Q to the second. Now it's a positive 2. All right, so that's what it looks like after I move all the negative powers. Now I need to do some simplifying. I can take care of this. Negative divided by negative is positive. That's one thing. 3 and 12 have a common factor of 3, so that's going to be a 1. 12 divided by 3 is 4. Okay, so there's that. On the variable side, I have r to the first and r to the third. 1 plus 3 equals 4, so I have r to the fourth. S to the fourth, S to the fifth. 4 plus 5 equals 9, so S to the ninth. On the bottom, q to the 1 and q to the 2. So 1 plus 2 equals 3. That's q to the third. Holy buckets. Now let's look at what we have. We have 1, r to the fourth, s to the ninth. On the bottom, 4, q to the fourth. Now again, this is a perfectly fine answer, but you wouldn't see it like that on a multiple choice test because we don't need that 1. It's not doing anything for us. So r to the fourth, s to the ninth over 4q to the fourth. Whew, there we are. Number 10, rock and roll. So this is negative right away. I see that that needs to move down. This is negative, and that is negative. Those are all moving up. Holy buckets. You can see how this gets messy, especially if you don't have the nicest handwriting. So hopefully you're writing kind of neatly if you can. 24, we didn't move. Y to the fourth, we didn't move. X to the positive 3, y to the positive 2, z to the positive 1. All of that moved up from the bottom. Bottom, negative 6, didn't move it. X to the negative second is now x to the second on the bottom. Moved it down. Okay, so now let's combine. Fraction, negative 24 over 6. They have a common factor of 6. If I divide by 6, I get a 4. There, I get a negative 1. That can go away too. And then variables. This is, well, the y's are going to be y to the fourth, x to the or y to the second, that's y to the sixth. So I have a 4, y to the sixth. Then the x, I have x to the third, and z, I have z to the first. On the bottom, I have that negative 1x squared. I still can get rid of some x's because, again, you only want to see each variable one time. X to the third over x squared. 2 are going to go away, leaving me with 1. If I write them in alphabetical order, as we usually see them, it looks like this. X to the first, y to the sixth, and z to the first, all over negative 1. Now, this is a perfectly fine answer, but if this were a multiple choice test, you wouldn't see it like that. You would see this negative up front outside of the 4 because dividing by 1 doesn't make a difference. So you would see negative 4x, y to the sixth, z to the first. All right, there it is. Number 11. Oh, now we're getting into some power of powers. Anytime you see those parentheses, that's power of powers. So that power that's on the outside has to go to everything on the inside. So I like to reduce the inside first. The more you reduce on the inside, the less you have to worry about changing afterwards. So I'm going to take a look at what I have inside the parentheses. So I have a c squared on top. I have d over d to the fifth. This is d to the first. So I can get rid of this d and make this d to the fourth. So really I have, I'm going to change the screen so it's a little bit easier to look at. and right on. Oops, that's not what I wanted. Oh, come on. There we go. There. So really I have parentheses, oh, now I'm writing in blue, parentheses c squared over d to the fourth. I haven't touched the power of -1. So now here's what you need to think about that negative power outside. When you've got a negative power outside, it's making everything on the inside raised to that negative first power. So everything that's on the top needs to move down to the bottom. Everything that's on the bottom needs to move up to the top. So basically, all you're doing is flipping the entire fraction. So that's what I'm going to do. I'm going to flip the whole fraction. D to the fourth goes to the top, c squared goes to the bottom, and I make this positive. So that -1 turns to a +1. Then I can worry about the +1 on the outside. Do I need to distribute it? Well, this is power of powers. Multiplying by 1 doesn't change anything, so I don't need to worry about that. I have d to the fourth over c to the second. No fraction to reduce. Variables are there only once. That's it. I'm done. Now let's take a look at number 12. This is where it's going to get a little bit tricky because now we have a -2 power. So again, start on the inside. The smaller you make the inside, the easier it is afterwards. So x squared on top over x on the bottom, I can get rid of one of those and get rid of the one on the bottom, and that's what I have instead. So 3x over y to the fifth. That's still all raised to the -2. I didn't do anything. So now I need to flip the whole fraction. Whoop. Everything on the bottom is going to go to the top. Everything on the top is going to go to the bottom. Power becomes positive. So y to the fifth over 3x, all raised to the second. Now you can distribute that power. So this power of 2 needs to go to the y to the fifth, it needs to go to the 3, and it needs to go to the x. So 5 times 2 gives me 10, y to the 10th. 3 squared is 9, and x to the first to the second, 1 times 2 is 2, so x squared. Y to the 10th on top, 9x squared on the bottom. Everything is simplified, and I'm done. Notice that my answers don't have any parentheses. I can't leave those parentheses in there. I've got to fix it. So one thing we're taking care of. So we're going to do a couple more of these and go from there. Make this a little lighter so we can see a little better. There we go. So in number 13, I have x to the -3rd y over x to the fifth, all raised to the -1st power. Again, simplify the inside. It's going to make your life easier. So I'm going to move this down. I end up with a y on the top, x to the third, x to the fifth on the bottom, still raised to the -1st power. That is y on top, y by itself on top, and x to the 8th, all raised to the -1st power. Now it's funny because we just moved some of the stuff on the inside, and now we're going to have to flip the whole thing again because of this negative power, but that's okay, we can do it. So when I flip it, now it's x to the 8th on top, y on the bottom, raised to the +1. Raising to the +1, when I multiply, doesn't matter. 1 times 1 is the same, 8 times 1 is the same. So x to the 8th over y to the 1st. Okay. Number 14, last question. So all that stuff on the inside raised to the -2 power. Again, simplify the inside first. I recognize this. Hello, let's reduce that fraction. It's going to make our life easier. So I know that that's going to be a 2/3. Here's the other thing that I can fix. X to the third over x, 1 can go away and I can make that a power of 2. This y to the -2nd goes up, so that's y to the first and y to the second. So I have x squared on top and now y to the third on top because I had a y to the first and now I have a y to the second. Still raised to the -2, I haven't fixed that at all. So now I'm going to flip it. Whole fraction flips, this becomes positive. So I have 3 by itself on top, 2x squared y to the third on the bottom. Now raised to the positive 2 power. Square that, square that. This is going to be times 2, that's going to be times 2. 3 squared is 9. 2 squared is 4. X to the 2 times 2 is x to the 4th. Y to the 3 times 2 is y to the 6th. So check your fraction again, because now we've done some squaring. Are there new factors we have to worry about? And no, there are not, because 9 over 4 cannot be canceled or simplified. X to the 4th, that's the only x. Y to the 6th, that's the only y. I'm good. That's my answer. All right. Thanks for tuning in and listening. Don't forget to check your note sheet off with Miss Johnson and get working on that practice assignment. Have a good day.